Hey guys, how are you today? Hope you're doing well. We are going to continue with stoichiometry today. So far, we have converted between particles and moles and liters and moles. Today, we're going to be converting between grams and moles, or mass and moles. And how we're going to do that is we're going to be using molar mass. Well, what is the molar mass of a compound? The molar mass is the number of grams per mole of any substance. So when we calculate the molar mass, what we're calculating is the number of grams that are in 1 mole of that substance. And again, this when we're talking about a substance here, that's going to be element or compound. That's what we're looking at here. So how do we calculate the molar mass of an element or a compound? Well, if it's an element, all we have to do is just look at the periodic table. We look at that decimal number and we round it to the first place past the decimal, okay? But if we are doing a compound, we're still going to use the masses of the elements from the periodic table, but we're going to add them all together. Right? And then the masses are going to be from the periodic table. So you're going to add the masses from the periodic table of all the elements in the compound. You're just going to add them all together. And again, when we get these masses from the periodic table, we will be rounding the masses to the first place past the decimal. Okay, and then why? Why do we want to convert between, or why do we want to determine molar mass? The reason we want to determine molar mass is because that's what we're going to use to convert between mass and moles. And again, that mass is in grams. I don't know why this has done that. I thought I had this all ready to go, and for some reason it isn't. Okay, so molar mass is used to convert between mass in grams and moles. And so that's why we're even doing this today, so that we can convert between mass and moles. So what we're going to do now is we're going to practice calculating molar mass. And you guys, I have 3 problems here for you to do this. I'm not going to do these 3. You're going to do them yourself. I'm going to do 2 or 3 other examples. Now, what you're going to do is just like what we've been doing for the last 2 or 3 units. You're going to do your work on a piece of paper. You're going to take a picture of your work. You can do all 3 of these on the same page. Take a picture of that and insert it onto this slide so that I can see your work, because I want to see how you do this. So let's go ahead and do a couple of examples. And I'm also going to go ahead and open up my scientific calculator here on Google. All right. And I also need a periodic table pulled up. So let me do that really quickly as well, because I know some of these masses, but I don't know all of them. And so I'm going to pull up a periodic table to use as well. And none of these are going to be any good. Let me go back to my... Okay, so anyway, this is a periodic table that I pulled up, and I will also put this on your PowerPoint for you to use to look at. So let's go ahead and look at some compounds. We're going to look at 2 or 3 different compounds. So again, if you're just looking at an element, guys, all you have to do is just say, okay, I need the mass of iron. Well, I just look here at iron. Iron is 55.85. Okay, so again, remember I need to round to the first place past the decimal. To do that, I need to look at the second place. So this 5 does cause this 8 to become a 9. So I would say the molar mass for iron is 55.9, and I would leave it at that. Okay, so if you need an element, you just look on the periodic table, round that mass to the first place past the decimal. Again, you have to look at the second place and see if that causes the first one to move up or to stay the same. So, but when it comes to a compound, we're going to have to add the masses of all the elements in the compound together. So when we look at this compound, Ba3N2 barium nitride, we see that it has 3 bariums and 2 nitrogens. So you guys, when we're doing the molar mass, we have to take that into account. So what I'm going to do is I'm going to write down the elements that are in this compound. So I'm going to write down there are 3 bariums and there are 2 nitrogens. Okay? So basically what that means is I need to do the mass of barium 3 times and I need to do the mass of nitrogen 2 times. So what I'm going to do is I'm just going to multiply those. Now you could add the mass of barium 3 times plus, add the mass of nitrogen 2 times plus, and then get your answer. But what I'm going to do, I'm going to multiply 3 times the mass of barium, 2 times the mass of nitrogen, then I'll add those together because that'll be a little bit quicker and easier. So I've got to look on my periodic table for barium. Barium is Ba. We see the mass is 137.33. This second 3 will not change this first 3. So my mass rounded to the first place past the decimal will be 137.3. Okay, nitrogen. The mass of nitrogen is 14.01. This 1 does not change to 0, so it's just 14.0. And then I'm going to multiply 3 times 137.3. 3 times 137.3 is 411.9. So for barium, it's 411.9. Now for nitrogen, 2 times 14.0, I can do that in my head, it's 28.0. Then we're going to add these together. So I'm going to take the 411.9 and add 28.0 to it. And that gives me 439.9. So guys, what that means is that there are 439.9 grams of barium nitride in 1 mole of barium nitride. So you guys, what does that look like to you? 439.9 grams equals 1 mole. And again, this is for barium nitride. Does that look like a conversion factor? That is a conversion factor. So you guys, we find the molar mass so that we can convert between mass and moles. Once we find that molar mass, this is our conversion factor, okay, that we can use in our factor label problems. All right, let's go ahead and do another one. Notice here I have parentheses. So remember what we did when we were balancing equations. To determine the number of atoms, there are a couple of ways you can do this. You can say, okay, that's NH4 twice. Okay, so I could write down NH4 twice and then count up and add up how many nitrogens and how many hydrogens. Or I can just multiply. Multiply what's on the inside times what's on the outside. So NH4 in parentheses 2. So again, that means there's 1 N, since there's no subscript, it's a 1. And you guys, this should be a subscript of 4. Okay, so what this means is there's 1 nitrogen and 4 hydrogens, and then there's 2 of each. So what I do is I multiply what's on the inside times what's on the outside. 1 times 2 is 2 nitrogens. 4 times 2 is 8 hydrogens. Okay, there's no subscript here, so we know that's a 1, so there's 1 sulfur. And the subscript of 4 on the O means there's 4 oxygens. Okay, so once we have done, this is very similar to what we did when we were balancing equations. We have to be able to look at that compound and tell how many of each element are there in that compound. 1 times 2 is 2 nitrogens. 4 times 2 is 8 hydrogens. No subscript there, so that's a 1 for the sulfur, and this subscript of 4 is a 4 for the oxygen. Now we're going to find our masses on the periodic table and multiply. So nitrogen, we already know, was 14.0. Hydrogen is 1.01. This 1 does not change that 0, so it's 1.0. Sulfur is 32.07. This 7 does change that 0 to a 1, so that's 32.1. And then oxygen, 16.00. That's 16.00. That second O does not change that first O, so it's just 16.0. Now we multiply 2 times 14.0. 8 times 1.0, 1 times 32.1, and 4 times 16.0. And then I'm going to add all of those together. So 28.0 plus 8.0 plus 32.1 plus 64.0 gives us 96.1. And what that tells us then is that there are 96.1 grams in 1 mole of NH4 2SO4. Okay, let's try one more here. The subscript after the Al tells us that there are 2 Als. There's no subscript after the C, so we know it's a 1. Now, this is CO3 with a subscript of 3 on the outside, so we're going to multiply what's inside the parentheses times what's outside the parentheses. So 1 times 3 is 3 C's. 3 times 3 is 9 O's. Then we find our masses on the periodic table and multiply. So aluminum, 26.98. Well, that 8 rounds that 9 up to a 10, which means this 6 becomes a 7. This is 26.98 is 27.0. Carbon, 12.01. This 1 does not change, this 0, so this is 12.0. And oxygen, we already said, was 16.0. Now we multiply. 2 times 27.0 is 54.0. 3 times 12.0 is 36.0. And then 9 times 16.0. I don't know what that is off the top of my head. 9 times 16.0 is 144. Then we add everything together. 144 plus 36 plus 54. So 144 plus 36.0 plus 54.0 gives us 234, and that's going to be 234.0 because again, we should be doing one place past the decimal. So 234.0 grams. Did I remember that? Yep, 234.0 grams in 1 mole of Al2 CO3 3. That's aluminum carbonate. Again, you guys, we do this because this gives us our conversion factor. And again, because all these elements have different masses, the mass is different. Now, again, for the particles, for the molar volume, the conversion factor did not change because for any gas, 22.4 liters in 1 mole. For any substance, there's 6.02 times 10 to the 23rd particles in 1 mole. But when it comes to grams, the conversion factor changes because all these elements, their atoms have different masses. So when it comes to mass, it depends upon the elements, the compound that you're looking at, as to what the conversion factor is. So we have to use the periodic table to get the masses and to get the conversion factors for when we're doing the conversions between grams and moles. Okay, so then let's go ahead and look at how we would do this if we just had the name of the element. What if we just had the name of the element? You guys, you're going to have to write the formula. This is the reason why I told you in Unit 4 we were going to be using this the rest of the semester. So if I don't give you the formula, you're going to have to write the formula before you can find the molar mass. So let's look at these are 2 that you're going to do on your own. Let's look at one that I'm going to show you as practice. Let's say that we're going to do lead for sulfite. Let's say we're going to do lead 4 sulfite. So lead 4 sulfite. Again, you got to have the formula before you can find the molar mass. So lead 4, I know lead is Pb, and I know that Roman numeral 4 means the charge of the lead is +4. Sulfite from my polyatomic ion sheet is SO3, and it has a -2 charge. And I will also put that polyatomic ion sheet on your PowerPoint so that you will have that to refer back to when you need it. Okay, once I get my symbols and my charges, then I'm going to crisscross. So I'm going to have Pb2 SO3, 4. Now, again, looking at these subscripts, 2 and 4 will reduce. Again, remember, you can't change anything in the parentheses. You can only reduce, if you need to, the things outside the parentheses. So both of these will divide by 2. This will become a 1, and this will become a 2. So my final formula is PB SO3, 2. Okay, once I have that formula, then I can do my molar mass. So I want to do the molar mass for lead 4 sulfite. So again, there's no subscript on the lead, so we know it's a 1, so there's 1 lead. Okay? There's no subscript on the S, so we know it's a 1. And then remember, we multiply what's inside the parentheses times what's outside the parentheses. So 1 times 2 is 2. Multiply what's inside the parentheses times what's outside the parentheses. So 3 times 2 is 6. Okay, now once we know the number of atoms of each element in the compound, now we're ready to look the masses up on the periodic table and multiply. So we got to look up lead, or PB, first. It's 207.20. This O does not change this 2, so it would be 207.2. For sulfur, we already did that one on the other page, but we can look at it again. 32.07. The 7 makes the 0 become a 1, so this is 32.1. And then the oxygen is 16.00, so when you round that to the first place past decimals, just 16.0. Now we're going to multiply. 1 times 207.2 is 207.2. 2 times 32.1 is 64.2. And 6 times 16 is 96.0. Then we're going to add all those together. And so we're going to do 207.2 plus 64.2 plus 96.0. And that gives us 367.4. So this is 367.4 grams is equal to 1 mole of lead 4 sulfite. Again, when we find these molar masses, that gives us our conversion factor to convert between grams and moles for that compound. This is only for that compound, so it will be different for every element. It will be different for every compound. Now, again, the only way this problem was different from the others that we did is that it only gave us the name, so we had to write a correct formula. We have to get a correct formula before we can do the math. So, guys, if you don't get this formula correct, your math will not be correct, and then your answer to the question will not be correct. So now let's look at how we're going to use these molar masses as our conversion factors. So what is the conversion factor to convert between moles and mass, which is grams? Well, it is 1 mole is equal to the molar mass in grams. And where are we going to get that? We're going to get that from the periodic table. So again, you guys, when you're doing mole mass conversions, mass mole conversions, whatever, you have to use the periodic table. Anytime mass is involved in doing these molar conversions, you're going to have to use the periodic table. So again, I have 3 slides here where you are going to be converting between mass and moles. And so these are your practice problems to do on your own. Again, you are going to be doing it on a piece of paper, taking a picture, and inserting it on this slide. Again, please make sure that your answers are labeled, that your work is labeled, number 1, number 2, whatever. And then you can do both of these on the same page and insert that picture on this slide. So let's go ahead and look at some practice problems. Okay, so our first one, how many moles are in 15 grams of lithium? So guys, remember, I'm going to go ahead and write down our conversion factor, the conversion factor we just wrote down. 1 mole is equal to the molar mass in grams. And again, that is going to be from the periodic table. Okay, so again, we are using the periodic table here. This is our conversion factor that we're using. So we're going to start out just like we always do. How many moles are in 15 grams of lithium? Well, we have 15 grams here. That's our given. How many moles is what we're looking for. So 15 grams over 1. Put your given over 1. Now remember, units come first. We want to cancel out grams. So where does it go? It goes on the bottom. What goes on the top? What we're looking for. We're looking for moles. Now let's use our conversion factor. 1 mole, 1 mole. Molar mass in grams from the periodic table. So what goes in front of grams? Well, the molar mass. Where do I get the molar mass? From the periodic table. So I've got to do the molar mass for lithium. So let's look up the molar mass for lithium on the periodic table. Here is lithium, 6.94. This 4 does not change this 9, so it's 6.9. What that means is that there are 6.9 grams in 1 mole of lithium. So 1 mole, 1 mole, 6.9 grams, 6.9 grams. Again, doing it just like we've done all the others. The only difference is it doesn't give us everything we need in that conversion factor. We have to go look on the periodic table to find the number of grams in 1 mole of that element. So now grams cancel out. We're left with moles, which is what it's asking me for, so that's good. So on the top, multiply. 15 times 1 mole is 15. On the bottom, 1 times 6.9 is 6.9. Then we're going to divide. 15 divided by 6.9. Sorry. Equals. And again, remember, right now we're just going to round 2 places past the decimal. So 2.17. This 3 does not change this 7, so it's 2.17. And that's 2.17. Don't forget moles. Okay? So, just like we've been doing the whole time, take what you're given, put it over 1, set it up so that your units cancel, then get your numbers from the conversion factor. The only difference is we have to find the numbers from our conversion factor on the periodic table. Let's do another one here. How many grams are in 4.5 moles of sodium fluoride? So again, 4.5 moles, how many grams? This is our given. So take our given and put it over 1. 4.5 moles over 1. Now we want to cancel out moles and solve for grams. So where does moles go? On the bottom. Solving for grams, so that goes on the top. Now we're going to use our conversion factor that relates grams and moles. Again, 1 is in front of moles. What goes in front of grams? The molar mass from the periodic table. So what am I looking for on the periodic table? Again, up here I was looking for lithium. This is not lithium. This is sodium fluoride, NaF. So I have to do just what we did with molar mass. There in this compound, there's no subscript after the Na, so it's 1. There's no subscript after the F, so it's also 1. So there's 1 Na. There's also 1 F. Then we got to look up the masses of those two on the periodic table. So Na is sodium, 22.99. The second 9 rounds the first 9 to a 10, so that becomes 23. This is 22.99 rounds to 23.0. Fluorine is 19.00. The second O doesn't change the first O, so 19.0. Then we multiply 1 times 23, 1 times 19, and then we add 23 plus 19. And I know that that is 42. So what that means is there are 42.0 grams in 1 mole of NaF. So again, one goes in front of mole, what goes in front of grams? 42.0. So you guys, anytime it's talking about grams, you have to find your answer from the periodic table. All those numbers that you get from the periodic table are grams. So anytime grams is part of the question, you're going to have to use the periodic table to get those grams. So now on the top, we have 4.5. Again, moles cancels out. I should do that first. We have 4.5 times 42.0. So 4.5 times 42.0 equals 189. 189. And that is grams. On the bottom, we have 1 times 1. So our final answer here is 189 grams. And again, what that means is there are 189 grams of NaF in 1 mole of, or in 4.5 moles of NaF. There's 189 grams. So you guys, when you have grams, it also is a good idea. This will be important for us starting Thursday. when we're looking at grams, it's also probably important to put the substance that you're talking about. So here we had grams of lithium, we converted to moles of lithium. Here we have moles of sodium fluoride, we converted to grams of sodium fluoride. That will be important to us come Thursday, that we know what substance it is that we're talking about. Okay, let's do some more. How many grams are in 2.75 moles of calcium phosphate? So we are given 2.75 moles of calcium phosphate. We're asking to solve for how many grams. Okay, so we're going to take what we're given, 2.75 moles, and we're going to put it over 1. Again, we're given moles. We want to solve for grams, so we're going to cancel out the moles. So moles goes on the bottom. We're solving for grams, so that goes on the top. So now I'm ready to use my conversion factor to get my numbers. Well, remember, 1 mole is equal to the molar mass in grams. And that's from the periodic table. So what goes in front of mole? Well, 1 in front of mole in my conversion factor, 1 in front of mole in my problem. What goes in front of grams? Well, molar mass goes in front of grams. Where do I get it? From the periodic table. So what do I look for on the periodic table? I look for calcium phosphate. Well, notice, guys, this does not give me a formula. So I've got to write a formula before I can do this problem. So calcium phosphate. So calcium is Ca. It's in group 2, so its oxidation number is +2. Phosphate is PO4. It's from the polyatomic ion sheet. Its charge is -3. Then we're going to do our crisscross. Ca3, PO4 in parentheses, 2. Again, this 3 and this 2 cannot reduce, so we leave it as it is. So now we have our formula. Now we can do our molar mass. Ca, the subscript is 3, so there's 3 CAs. P, there's no subscript, so it's 1. Notice it is inside the parentheses, so we have to multiply what's inside times what's outside. So 1 times 2 is 2. So there are 2 phosphorus. Oxygen, there are 4 inside the parentheses, 2 on the outside. 4 times 2 is 8. So there are 8 oxygen. So now we're going to multiply times the molar masses from the periodic table. Calcium from the periodic table is 40.08. This 8 rounds this 0 up to a 1. So this is 40.1. Phosphorus, 30.97. This 7 rounds this 9 to a 10, which means this is going to be a 1. So 31.0. 30.97 rounds to 31.0. And then oxygen is 16.00. So the second 0 doesn't change the first 0, so it's just 16.0. Then we're going to multiply. 3 times 40.1 is 120.3. 2 times 31 is 62. And then 8 times 16. I'm going to have to multiply that one out on the calculator. 8 times 16.0 is 128. Then we're going to add all these together. 128 plus 62 plus 120.3. And we get 310.3. And what this means is there are 310.3 grams in 1 mole of calcium phosphate. Again, make sure you write that formula correctly before you do your molar mass. So now, guys, this is my conversion factor. 1 mole, grams, 310.3 in front of grams in the conversion factor, 310.3 in front of grams in my problem. Moles cancels out. Now we're going to multiply. 2.75 times 310.3. 310.3 times 2.75 gives us, and again, we're going to do 2 places past the decimal here, 853.32. The 5 does round this 2 up to a 3, so 853.33. 853.33 grams on the top. On the bottom, 1 times 1 is 1. So our answer is 853.33 grams. And again, this is calcium phosphate, Ca3, PO4, 2. So what that tells me is 2.75 moles of calcium phosphate is equal to 853.33 grams of calcium phosphate. Okay, guys, that is it. I've done at least one example of each type of problem that you're going to need to do for me. Again, you have 2 slides, which are 5 problems where you're calculating molar mass, and then you have 3 slides, which is 6 problems where you are calculating or where you are doing conversions from moles to grams or grams to moles. Please let me know if you have any questions, and I'll be talking to you soon. Bye-bye.